Form 2 Mathematics. Today I would like us to look at linear motion, a linear motion question here which was tested in KCSE in 2014. Welcome. So the question reads, the figure below represents a speed time graph for a cheetah which covered 825 meters in 40 seconds. 825 meters in 40 seconds. So here we have the graph. Here we have the graph of speed in meters per second against time. I hope you can see this, learners. Time in seconds. So we have a graph that takes this shape. So we go direct to question A. State the speed of the cheetah when recording of its motion started. State the speed of the cheetah when the recording of its motion started. Learner, which speed is this? The speed at the starting. The speed at time is equals to 0. What is the speed at time is equals to 0? You go to the graph when t is 0. What is the speed? It is 15 meters per second. So the speed is 15 meters per second. That one is as direct as that. State the speed of the cheetah when the recording of its motion started. That is at time 0. So at t0, the speed is 15 meters per second. Good. We go to part B. We are told to calculate the maximum speed attained by the cheetah. What is the maximum speed? Maximum speed attained by the cheetah. Where do we get this maximum speed in our diagram, learner? So this is the shape that we have. This is the figure that we have here. So the maximum speed is indicated by this length here. Maybe I can draw a line here. If you look at this figure, learner, the only maximum speed that we can have is from here to here, which can also refer from here to here. It is this height around here. So let us call it x. Our maximum speed, because like here it was 15, the speed increased up to where? Up to here. So the maximum speed can be read at this point there. Call it x. So what is the maximum speed? What is this x, learner? So what you do is that you relate everything to the distance covered. The distance covered in a speed time graph, learner, is equals to the area of this shape here. The distance covered, maybe I can write that. The distance covered is equals to the area of the plane figure that we have there. And therefore, we are told that the distance covered here is 825 in 40 seconds. So the distance covered is 825 in 40 seconds. So this area here is 825, learner. 825, just like the distance. So we get the area. We get the area for A, we get the area for B. Adding the two areas, we should get 825. So, learners, looking at the first figure here, this is a trapezium. How do you get area of a trapezium? It is, so maybe you can go about it direct. We can say it is a half sum of the parallel lines, that is, here we have 15 that corresponds to this 15 here. So we talk of half of the sum of 15 and x on this other side. Those are the parallel lines. Sum of parallel lines times the perpendicular height. I hope you can see this. The perpendicular height here is 10. So like that. That is the area for our trapezium A. Then we move on. The second figure here, learner, is still a trapezium. You have this side and this side being parallel, and you have a perpendicular From here to here, Lana, it corresponds from to what? 10 to 20. So 20 minus 10 gives us 10. So this length is 10 here. And therefore, from here to here also it is 10. Because actually this 20, if we were to draw a line like that, Lana, line like that, it would touch that point up there. So 20 minus 10 gives us 10. So even here it is 10. And down here, Lana, our trapezium starts from here. So from 10 all the way to 40. So this is 30. 40 minus 10, the length here is 30. So we talk of our area of the trapezium will be a half 10, the upper side, plus 30, the lower side, times the height of our trapezium, Lana. The height of our trapezium, I hope you can see it. So 10 and 30, and our height is still x. Look at this. Our height this time still refers to x. So we fix our x there. I hope you can see. Oh, sorry, Lana. This is 10 plus 30. The other parallel line down here is 30. Okay, so your height is x, as we have seen. There we are. All these should add up to 825, our area. So I hope you have got that point. It is the area of this trapezium which is starting vertically. So this side is 15 and this is x. There we are. Plus the area of the second trapezium whose parallel lines are 10 and 30, and the height is this one here. The height this time round is your x. So from there, Lana, we remove these brackets. So we can say by 2, 1, by 2, 5. So there we are left with 5 in brackets, 15 plus x. I hope you can see that. Plus what, Lana? This is a half of what? A half times 40, and then times x, which is equals to 825. So we remove these brackets, we talk of 75 plus 5x plus a half times 40 is 20, so 20x. 20x, Lana. It's a matter of now being accurate here. There we are. From there now, we put the like terms together. This plus this, Lana, gives us 25x is equals to 825 minus 75. You take 75 to this other side. So 25x, therefore, is equals to 750. Divide by 25, divide by 25, and therefore, what is your x? What is your x? Your x is 30, which refers to the maximum speed. And therefore, we say the maximum speed of the cheetah, Lana, the maximum speed of the cheetah is 30 meters per second. You fix the units there. From there, Lana, we continue with the question. It was a 10 marks question. 10 marks question. So here we go. 10 marks question. So you are told, calculate the acceleration of the cheetah in the first 10 minutes. Calculate the acceleration of the cheetah in the first 10 minutes. Let me fix our figure here. What is the acceleration of the cheetah in the first 10 minutes? So here we have 0 to 10 minutes. So how do you find acceleration, Lana? Acceleration in mathematics or even in physics is given by final velocity or speed, which is v, minus initial velocity or speed, which is u, divided by time taken. So we come to this part here of the graph where there is acceleration. We talk of the initial speed. Our initial speed is 15. This one here. This is our initial speed, and our final speed is at this point here, which is 30. We had got this as that 30, which corresponds to the 30 on the y-axis, so 30. So our u is 15 and our v is 30. Our v is 30. So what is our a? Our a therefore will be equals to 30 minus 15, the initial, divide by our time here, 10. We are talking about the first 10 seconds, divide by 10. So this gives us 15 over 10, which is 1.5. And therefore, meters per second squared. This is our acceleration in the first, 10 seconds, learners. I hope we are together. We go to part 2, learners. Find the acceleration of the cheetah in the last 20 seconds. Where are the last 20 seconds? Here we go. 20 seconds, they start from 20 to 40. In other words, 40 minus 20 gives us 20. So we are talking about this part here, whereby our initial velocity corresponds to this point there, which is 30. Remember, this and this are equal, so 30. And our final velocity here is what? What corresponds to here? This is 0. 0, the final velocity. And our time is 20. So again, acceleration is equals to v minus u over t. Look at that, learner. Our final velocity is 0. Our initial, which corresponds to 20, our initial is 30. I hope you understand, over 20 seconds. And therefore this gives us negative 30 over 20, which gives us what, learners? Negative 1.5 meters per second squared. So our acceleration here is negative. We call it deceleration. Look at that. That is our acceleration this time round. Finally, learners, what are we asked? We are asked to do what? To calculate the average speed of the cheetah in the first 20 seconds. Average speed of the cheetah in the first 20 seconds. That is from 0 here all the way to 20. What is the average speed from 0 to 20? Learner, average speed is given by distance over time. Distance covered over time. We don't have the distance, so we need to calculate it, but we have our time. Our time, we are talking about 20 seconds. 20 seconds, learner. Therefore, we calculate the distance between 0 and 20. Learner, how do we go about it? So we talk of distance, which is the same as area, is given by area of this trapezium, which is standing vertically. This is a trapezium which is standing vertically, and then we have these. This is a rectangle of 30 by 10. 30 by 10. So our distance therefore will be equal to area of the trapezium, which is a half. 15 plus 30. Look at that. 15 plus 30. Plus, times what, learner? Times 10. The perpendicular height is 10. There we are. Plus area of our rectangle, which is 30. I hope you can see this, by 10. 30 by 10. There we are. So this gives us what, learner? This is a half times 45 times 10 plus 300. This gives us what? By 2, 1 by 2, 5, and therefore we get 225 plus 300, which gives us 525 meters. This is our distance. So learn, what is our average speed? Our average speed is equals to the distance covered, 525 meters, over our time, which is 20 seconds. This will finally give us 26.25 meters per second. That is our average speed. So learner, go through this question slowly as you internalize the concepts. Otherwise, I wish you all the best learners in linear motion. God bless you.